Hello, today we will be completing the electrolysis chapter with the application of electrolysis. What are the applications of electrolysis we will be discussing over here? Electroplating with nickel and silver. Choice of electrolyte for the electroplating. This will be discussed together with this. Electro-refining of copper. Here we will be discussing reasons and conditions for electroplating, names of the electrolytes and the electrodes used, equations, etc. Now, electrolysis has several technical and commercial applications like electroplating with metals, electro-refining of metals and extraction of metals or electrometallurgy. This will be discussed in details in the metallurgy chapter. Now, what is electroplating? Electroplating is a process in which a thin film of metal like silver, gold, nickel, chromium, etc. get deposited on the surface of an inferior metal or alloy like metals like iron, copper, and alloy like brass, or on an article made of it with the help of electricity. What are the reasons? Reasons for decorating purpose, like brass objects are frequently plated with silver to give them the shining appearance and beauty of a silver article. Second reason, to protect from rusting and corrosion. This is very common method. Iron tools and instruments are generally electroplated with nickel or chromium or zinc to protect against rusting. Different conditions for electroplating. First condition, the article to be electroplated is always placed at the cathode, because during electrolytic reaction the metal is always deposited at the cathode by gaining the electrons. Second condition, the metal to be plated on the article is always to be made as anode and has to be periodically replaced, because the metal anode continuously dissolves. That you have seen when you have electrolyzed the copper sulfate solution using copper as both the electrodes like cathode and anode. So similarly, metal anode generally dissolves as ions in solution and so has to be replaced periodically. Third point, electrolyte must contain ions of the metal which is to be plated on the article. So that is, be a suitable salt of the plating metal. The electrolyte dissociates into ions of the metal which migrate towards the cathode and are deposited as neutral metallic atoms on the cathode. So the solution is there which will be supplying the metal ion. Fourth point, a low current for a longer time should be used. Higher current causes uneven deposition on the metal. Longer time and low current will initiate a thicker and uniform deposition. And last is, a direct current and not AC current should be used. AC current causes discharge and ionization to alternate at the cathode, thus giving no effective to coating. So these 5 points are very important conditions for electroplating. Now we will go to electroplating of an article with silver. No, we will be going first to the electroplating of an article with nickel. Iron generally gets rusted when exposed to air. If iron articles are coated with a metal like nickel, tin or zinc, rusting can be prevented. If nickel plating has to be done, the iron article to be coated is made of cathode. So here only article to be plated is mentioned, whatever article you want to take. I am just telling about iron article. Nickel plate is made the anode. Nickel is the anode. And the solution of nickel sulfate containing a small amount of dilute sulfuric acid is used as electrolyte. So what is the electrolyte? Aqueous solution of nickel sulfate containing a small amount of dilute sulfuric acid. Cathode is cleaned article to be electroplated, let's say iron article. Anode is a block of nickel metal. So the aqueous solution of nickel sulfate will be dissociated into nickel +2 and sulfate -2. Also there is water in the solution because it is aqueous solution, hydrogen and hydroxyl. Now at cathode there will be nickel deposited. Nickel ions are discharged at the cathode as neutral nickel atom by gaining electron in preference to hydrogen ions. Next, reaction at anode. At anode, nickel is converted into nickel ion. There is sulfate as well as hydroxyl ion. All will be migrating to the anode, but they will not be discharged due to the nature of the electrode, as you have seen in the copper sulfate electrolysis with copper electrode. So here the nickel anode loses electrons to give nickel Ni+2 ions in the solution, and the article to be plated is kept at cathode. So that at cathode that nickel is deposited, and from anode nickel ion is going into the electrolyte. Next, electroplating with silver. To get the perfect deposition of the silver on any article like brass spoon, iron spoon, etc., the article should be cleaned. Now in case of nickel deposition also, the article should be always cleaned. So the cleaned, and then the article is washed with hot solution of caustic soda, followed by dilute sulfuric acid and water. It is now thoroughly washed with detergent and several times with distilled water. So this type of cleaning process can be followed with this process also when you will be doing the deposition with nickel also. So now here the spoon then dried and made the cathode. Here the cleaned article is kept at the cathode. Now anode is a block of silver. So the electrolyte is now sodium argentocyanide, or it is also taken as potassium argentocyanide, or commonly known as, those who cannot remember, they can say sodium silver cyanide, or you can take potassium silver cyanide. It is NaAgCN2, that is sodium silver cyanide or sodium argentocyanide. And in case it is KAgCN2, then it is potassium silver cyanide or potassium argentocyanide. Now, so this sodium silver cyanide or sodium argentocyanide or potassium argentocyanide, etc., are prepared by adding sodium cyanide to a solution of silver nitrate until you get a precipitate of silver cyanide, which will be dissolved in extra sodium cyanide. Similarly, if you want to prepare potassium argentocyanide, in case of sodium cyanide, you have to take potassium cyanide. And potassium cyanide is not generally used. It required special permission. So the dissociation is now taking place for sodium argentocyanide. Sodium plus, silver plus, and cyanide minus 2. 2 cyanide ions you are getting. Water is dissociated, hydrogen and hydroxyl. Now article is cathode. So there is the cleaned article. Silver is accepting electron and deposited on the cathode. And in anode, plate of pure clean silver. So silver loses electron at anode and goes into the electrolyte as silver plus. Now there are the negative ions like cyanide and hydroxyl ions. They migrate toward the anode, but none of them are discharged as the previous one. Instead, the atoms of silver anode, that is silver, lose electrons and pass into solution as silver ion due to the nature of the anode, where anode is the block of silver. Now silver ions are attracted towards the brass spoon, that is cathode. So now cathode, here this silver is getting electron and converted into silver atom, and now it is deposited on the spoon. As discussed earlier, thickness of the coating will be dependent on the duration of the current passed. In the process, the anode dissolves. In both the process of electroplating by silver as well as nickel, the anode dissolves. Electrolyte solution maintains the same concentration. Thus, if it is colored, the intensity of the color remains same because continuously anode is getting dissolved into the electrolyte, and time to time you have to replace the anode. Now after this, the spoon is taken out from the bath, washed with water, dried and polished. Now here, if silver nitrate solution is used directly instead of double cyanide of sodium and silver, deposition of silver will be very fast and there will be no smooth and uniform deposition found on the spoon. Then we will move toward the electro refining process of copper. Now electrolytic refining of metal is a process by which metals containing impurities are purified electrolytically to give a pure metal. Most important use of copper is in the form of wire for electrical transmission. So for this, copper should be extremely pure because of small amount of impurity can reduce its conductivity to a great extent. Here the electrolytic refining of copper is shown in two parts. One is shown in the laboratory how you can do, another is in the large scale. Both the principle is same. The electrolyte is a copper sulfate solution with dilute sulfuric acid, as you have seen in the previous section also. Cathode is a thin strip of pure copper. Cathode is a thin strip of pure copper. You can compare these two diagrams yourself also. And anode is an impure copper, which is also called anode mud. Sorry, there is the anode mud is deposited. Anode is a impure copper, anode mud is different. We will be discussing that. Next, now the current is passed through the electrolyte. Copper ions of the copper sulfate solution will be attracted towards the cathode. There they will be gaining the electron. So here you can see at cathode, copper ion Cu+2, which is present in the solution, copper sulfate solution, will be attracted towards the cathode. Okay, there they will be getting some electron, gaining some electron, and they will be deposited on the cathode as pure copper. So on the cathode they will be deposited as pure copper. Now the impure copper will lose electrons and passes into the solution. Impure copper, this is the anode. It will be gaining some electron at anode and it will be Cu+2. So it will be deposited, it will be dissolved into the electrolyte. So the reactions are shown over here at cathode and anode. Now copper ions migrate to the cathode in the form of precession. After gaining electrons from the cathode, it will be deposited on the cathode. Net result is that gradually the impure slab of copper you have used in anode. So the impure slab of copper get finished because it is getting dissolved by gaining 2 electrons. It is getting dissolved into the electrolyte, and you are seeing that thin strip of pure copper which is taken as cathode is getting the deposition of pure copper and getting thicker. So the copper deposited on the cathode will be 99.9% pure. After electrolysis is over, these strips are melted and transformed into desired shape. And some impurities get dissolved in the acid, while others like silver and gold, which are insoluble, get collected near the anode, and this is called anode mud. And then these are recovered. Metals like zinc, lead, mercury, silver and copper are refined or purified by electrolysis. Electrometallurgy will be discussed in the next chapter when we will be discussing the metallurgy. Thank you for your patience hearing.